All right, it's going to be opposite same. So the opposite of 8 is -8. The same as 9 is 9. It's concave down because of the negative out front. So the vertex is going to be -8, +9. And it opens down. So yes, it would be C. All right, the vertex again is opposite, so that's going to be -2, same, -4. So I'm going to go left 2, down 4, pop my dot. The axis of symmetry is x equals that -2. The domain is all reals. The range is going to be from that spot going up, so it's going to be bracket the y value -4 up to positive infinity. The large open interval that the domain that the function is increasing, that's going to be over here to the right, where I go up 1 over 1, up 1, 2, 3 over 1, up 1, 2, 3, 4, 5 over 1. That's where the domain is increasing. So that's going to be from the axis of symmetry, -2 to infinity. Now it's decreasing on the way down, up 1 over 1, up 3 over 1, up 5 over 1, but it's on the down slide from there, decreasing on that section. So that's going to be from -infinity to -2, like flip-flops. To find the vertex of this, I'm going to mode 5-3 in the calculator, mode 5-3. All right, after you mode 5-3 it, you don't want the x sub 1 or the x sub 2. You want the x val min, and the x val min is going to equal 3. The y val min is going to equal 1. And that's going to be your vertex. So 3, 1 is your vertex. You go right 3, up 1, and pop a dot. The axis is going to be x equals that x value, 3. The domain is all reals, -infinity to positive infinity. Now because there's a positive 1 in front, I'm going to go up 1 over 1, up 3 over 1, up 1 over 1, up 3 over 1.
When I graph it, do I just do 2? Well, my vertex is 2 and 1, so do I just go to 2 and 1 and then go up 1 over 1?
Yep. You're going to use 1, 3, 5 for these graphs. That means you go up 1 over 1, up 3 over 1, or you can go up 1 over 1 and back down, up 1 over 1 and get just those 3 points. The range is going to be from this lowest y value, which is 1. So it's going to be bracket 1 to infinity. The domain where the function is increasing, that's on this part going to the right of the axis of symmetry. So increasing is a parenthesis usually. So that's going to be 3 to infinity. And then it's decreasing from -infinity to 3. Number 4, again, I have to mode 5-3 it in order to get the vertex. You're going to mode 5-3 it in order to get the vertex. So my vertex, my x val min, or x val max is -5. My y val max is 12. It's a max because of the negative. That means it's going to be concave down. The axis is x equals that x value. The domain is -infinity to positive infinity. The range, well, if I go to -5 up to 12, -1, 2, 3, 4, 5, the range is going to be from -infinity up to that value. Because it's coming from the depths. And that value is going to be the y value of 12. Bracket on the 12, by the way, bracket on the 12. The largest open interval, the domain over which it is increasing, is going to be from -infinity all the way up to that x value of -5. So parentheses, -infinity to -5, but it's a parentheses on the increasing part. Decreasing is going to flip from -5 to infinity. By the way, to get this array of points, you don't use 1, 3, 5 necessarily. You use 1, 3, 5, but you multiply it by 3. Actually, -3. So there's my vertex, and from that spot, I go down 1, 2, 3 over 1. 1, 2, 3 over 1. It's going to be a narrow upside-down parabola. This one, I know it's going to be negative. I know it goes from -4, 4, so I'm going to use opposite, same. And it's going to be negative, but notice I go down 4 over 4. That's going to give me a 1/4 as a leading coefficient, a -1/4 as a leading coefficient. Number 6, I'm going to mode 5-3 this, and then get the solutions. All right, for number 6, we mode 5-3 it, and I get a couple of things. I get an x sub 1, I get an x sub 2, but I don't need that. I'm looking for the maximum height, and I'm looking how long it takes to reach the maximum height. So that's going to be the x value on my vertex, and this is going to be the maximum height, which is the y value on my vertex. So I get 1, 16. So it takes 1 second to reach a maximum height of 16 feet. Synthetic, backwards box, you put the opposite in of -3. Write down the coefficients of 1, 5, 8, 6. I put a 0 there. Do my arithmetic bar. Do my remainder column. Thank you. 1, -3 times 1 is -3. That's going to give me 2. That's going to give me -6. That's going to give me 2. 3 times that is -6. My remainder equals 0. And once x squared plus 2x plus 2 is my answer. Backwards box. I put -3. Coefficients are 1, 4, 3, 5, 12, -5. It's getting a little long. I put a 0 there. Remainder column. That's going to give me a 1. I multiply. That gives me -3. That gives me 1. That gives me -3. That's a 0. I have to save that place later. 0, 5, -15. 12 minus 15 is -3. -3 times -3 is 9. 9 minus 5 gives me a remainder of 4. So my answer is going to be x to the 4th plus x cubed, 0x squared plus 5x minus 3 plus 4 over the original x plus 3. This one I want to do synthetic on. backwards box. I put the 8, I put a 1x cubed, a 0x squared, a 0x minus 512. Put my 0 there, my arithmetic bar, my remainder column, 1, 8, 8, 64, 64, 512. My remainder is 0. My answer is x squared plus 8x plus 64. The format for this is really strange. The format for this is really strange. When it gives you that heading, it's going to be a little tricky. I immediately know that the first thing of my answer is going to be x plus 1, just because they gave me k equals negative 1. Now I'm going to do my synthetic with negative 1 in the backwards box. Notice how I just left it there like that. Put my coefficients, do my synthetic. That's going to give me 3. Negative 1 times 3 is negative 3. Negative 2. 2, 3. Negative 1 times negative 3 is negative 3. That gives me a remainder of negative 12. So x plus 1 is the first part of my answer from the format that they give me. Then that's going to be multiplied. That's my quotient right there. So that's going to give me 3x squared minus 2x plus 3. And then it wants me to add the remainder at the very tail end. So that's going to be minus 12. That one's a little tough, just because of the format. Again, the format is not that format. All they want me to do is plug in the negative 1. So I'm just going to do negative 1. You have to wrap it. You have to wrap it squared. Minus 3 times negative 1 plus 5. That's going to give me 1 plus 4 plus 5. I believe that is 10. Look how nice they are giving me an answer. I don't really need it. I'm just going to mode 5 for this and get the answers. If negative 2 is an answer, then that means this will equal 0. If negative 2 is not an answer, I have to actually plug it in and get the remainder. I think it's going to be an answer. So I'm going to mode 5 for this to check it. When I did the mode 5 for, my first answer was negative 2. So I can say that the given k is a 0 of the polynomial. Factor completely. To factor completely, we're going to mode 5 for it again. And whatever our answers are, x1, x2, and x3, those are going to be changed or transformed into our factors. They already gave me one of the answers is 5. So I know one of my factors is going to be x minus 5. They were so kind to give me that answer. So after I did the mode 5 for, my first answer is negative 8, then 5, then 3 halves. So I'm going to go in the order that my calculator gave me, negative 8, then 5, and then 3 halves. And the factors that it's going to turn into are x minus 5, x plus 8. And then this is going to be a little tricky. I have to multiply by 2. That would give me 2x. And then the opposite of plus 3 would be minus 3. So there's my 3 factors. Possible rational zeros are all the factors of 10 over the factors of 1, so it has to be choice D. Then I'm going to mode 5 for it to get the actual answers. Notice the calculator gives me negative 5, negative 1, and negative 2. Negative 5, negative 1, and negative 2. That's my solutions. Then my factors, my linear factors, are going to be x plus 1, x plus 2, and x plus 5. Another type of problem, factors of 75 over the factors of 15, but the trick is to find the plus minus 75. Let me see here. I accidentally skipped D, but it should have plus minus for each of these.
It's the same thing as A, but plus minus.
And it should have the plus minus, so it would be choice D in this particular case. Now I'm going to mode 5 for to get the actual answers. Mode 5 for gave me negative 25, that's 1/3, and negative 0.6. We'll see. Negative 25, 1/3, and negative 3/5 is actually negative 0.6. The factored form of that is going to be x plus 25, 3x minus 1, and 5x plus 3. Realize you have to change the signs when you write the factors. Find the zeros. So what makes this quantity 0 is 1, but it's going to have a multiplicity 5. So right now I have 1 multiplicity 5, 1 multiplicity 5. It's a toss-up between A or C. I solved that. I set that equal to 0. 3x plus 1 equals 0. That's going to give me 3x equals negative 1, or negative 1/3. So once again, it's a toss-up between A and C. No help. This, I can actually factor to x plus 4 to x minus 4, and that's going to give me 2 zeros of plus or minus 4. So it is actually choice C. This one is a little difficult. I have to FOIL this out. I'm going to make 2 Punnett squares, a 4 square Punnett square, a 2 by 2 Punnett square of x plus 3 times x plus 1, and then a 6 square Punnett square. And that's going to be x minus 4. The inside is going to be x squared, x, 3x, 4. That's going to go up here, x squared, 4x. Notice I added these two up, plus 4. Now I have to fill this in. That's going to give me x cubed plus 4x squared plus 4x minus 4x squared. Well, those are going to cancel out. Minus 16x minus 16. Nah, something's wrong. That should be a 3 there. Minus 12. 1 times 3 is 3. This should be a 3x. A 3x. Now when I combine, that's going to give me x cubed minus 13x minus 12. I already had it done. See, it shows up all the time. But they want me to plug in negative 2. So negative 2 cubed minus 13 times negative 2 minus 12. That's going to give me negative 8 plus 26 minus 12. That equals 6. F of negative 2 equals 6. But they want it to equal negative 12. So what do I have to do to 6 to make it equal to negative 12? Multiply it by negative 2. So I'm going to take this and multiply that by the negative 2. So it's going to equal negative 2x cubed plus 26x plus 24. And that's the polynomial that I was looking for. Possible number of positive real zeros. This is called Descartes, rule of signs. And all we do is count sign changes. Notice there's one sign change from there to there. There's one sign change from there to there. That is two sign changes. There's the one sign that is 3 or 1 possible positive real roots. The reason it goes down by 2s is because you can only have 2 not real roots. Now, in order to find the negative sign changes, I'm going to plug in a -1 for each x value. So that's going to be -6 times -1 cubed plus -1 squared minus 9 times -1 plus 4. I'm not going to add these up. I just want to see what the sign is. So this is going to be +6. This is going to be +1. This is going to be +9 and +4. Notice there are 0 sign changes, so there are 0 possible negative real zeros. Possible number of non-real complex zeros. You cannot have 3 complex zeros. They go in pairs or none. 19, it wants to know the zeros of this. That's -7. That's -1, but it touches and turns. Goes through 2. Goes through 7. It's down on the left, up on the right. Notice it is -x to the 5th. So it wants the factored form. It's going to be x plus 7. X plus 1. However, it touches and turns there, so that's going to be squared. X minus 2, the opposite of plus 2. X minus 7. And I'm done. End behavior, positive x to the even is going to be up. It's sort of the same end behavior as y equals positive x squared. It is going to be up. 21, I have to factor it, so I'm going to mode 5, 4. All right, I got x of 1 equals -7, so that means there's going to be a 0 at -7. X of 2 is 1, there's going to be a 0 at 1. X of 3 is -3, there's going to be a 0 at -3. That's not enough to actually graph it. I actually need the 0, -21. 18, 20, 22, 24. And it's x cubed, so that end behavior is going to be down on the left, up on the right, and it should look something like this. X to the 4th. X to the 4th is going to be up. So it's either B or D. Now, in order to do this one, we have to do menu negative on the white calculator. We have to do menu minus on the white calculator to solve an x to the 4th. What I mean by menu minus is I'm going to hit the menu button, then I'm going to hit this negative button here, and it's going to ask me if I want to do a simultaneous or polynomial. This is x to the 4th, so that's a polynomial. Then I'm going to select the degree of 4, and then I'm going to do my normal mode stuff. I'm going to type in the leading coefficient of 8, and then -67, then 75, then 275, then 125. And it's going to give me the zeros. One of my zeros is 5. I've already ascertained that it's either going to be B or D. So since one of my zeros is 5, it might be D. Let me see what the other 0 is. -5/8, -1, 5, -5/8, and -1. I believe it's going to be D. It's going to be D. -1, 5, -5/8. Is 8 an answer? No, 8 is not an answer. 5, that's going to be there. -5/8 is going to be a little bit to the right, and -1 is going to be a little bit to the left. So it's going to be choice B. Tough to see. It actually dips down below over here and touches and turns at that one. This one's kind of nice, except for the 0, 24 is going to throw me off. The factors are going to be nice. It's going to be x plus 4. It's going to be x minus 2. And then it's going to be x minus 6. However, when I throw in a 0 for the x values, I don't think I get 24. When I throw in 0, I get 4 times 2 times 6, which is 48. Actually, it's positive 48, which is good, but what do I have to do to 48 in order for it to equal 24? I have to take half of it.
Oh yeah, they didn't do nonsense.
For this one, it goes through -3 and it goes through -2. It touches and turns. It's negative, so it's concave down. So it's going to be y equals, or f of x equals, x plus 3 squared, because it touches and turns there. X minus 2 squared, because it touches and turns there. But because it's down, I have to put a negative in front of the answer. The vertical asymptote is going to be the opposite of the -7. And the vertical asymptote is a vux. So it's going to be x equals 7. The same as that number kicking out there. That's going to be a horizontal asymptote, is a hoi. So that's going to be y equals 6. The range, so it's everything but 1. That means it's going to have a horizontal asymptote at y equals 1. This one looks like it has a horizontal asymptote at y equals 0. This one looks like it has a horizontal at y equals -1. Y equals 0. This one looks like it has a horizontal at y equals 1. 2, 4, 6, 8, 10. I don't know, maybe not. It might be this. It's going to be D. X-axis as a horizontal asymptote. A has an x-axis as a horizontal asymptote. B has the x-axis as a horizontal asymptote. C does not have the x-axis. D has the x-axis as a horizontal asymptote. So A, B, and D. 28. If I were to factor this, I believe I would get x plus, no, I can't factor it. Choose the x-axis as the horizontal asymptote. There is no horizontal asymptote because the degree of the top is bigger than the degree of the bottom. X-intercept, no. Vertical asymptote, no. A hole at 3, no. Oblique asymptote, yes, it has an oblique asymptote. I think that might be the only answer.